Good evening, everyone. I hope you all are doing great, and a very warm welcome to all of you for joining today. We have two presenters today, and I would like to invite Miss Saima Naz to come and give her presentation. She is doing PhD in 3S integration and meteorological application. Please welcome her.
I have to. Okay. It will just go like this. Okay. Hello everyone. I am Saima Naz and I am from Pakistan. Currently, I'm pursuing my PhD in 3S integration and meteorological applications from the School of Remote Sensing and Geomatics Engineering. My previous degree is also in remote sensing and GIS from the Department of Meteorology, Comsets University, Islamabad, Pakistan. Along with that, I have been part of one national and two international projects funded by Survey of Pakistan, D8 Secretariat, Turkey, and Harvard University, US. The topic I will be presenting today is my first publication entitled Marine Oil Spill Detection Using Synthetic Aperture Radar over Indian Ocean. As the topic illustrates, it's about marine oil spill, synthetic aperture radar, and over Indian Ocean. What an oil spill is? It's actually marine pollution. Whenever we think about pollution, it comes in our mind automatically that addition of harmful substance into the environment. So when we talk about marine oil spills, it means the addition or discharge of hydrocarbons into the marine environment. How it happens? Basically, with the Industrial Revolution, oil transportation has increased dramatically because resources are not distributed equally. Some areas are rich in oil, whereas some areas are oil deficient. So to meet the needs of industries, it has to be transport from the supply to the demand location. And this is usually happening via marine environment. Why? Because it is cost effective. So sometimes during this process, due to the human negligence or natural calamities, it discharges into the marine environment and become a disaster. Why? Because it's very persistent pollutant and it takes too long to degrade. Number two, it makes coating over the upper layers of the water and reduces the light penetration into the lower water layers. That is a hazard for the marine biodiversity. Oil spills effects are strongly affected by the meteorological and geographical phenomena of that particular areas. Whenever oil spills in a marine environment, 5 questions arise promptly. What happened? What would be the fate of that oil spill? What could it affect? And how harmful it could be? And how to eliminate it? How to mitigate? My study is actually focusing all these questions that I've conducted from 2017 to 2018 and investigated 4 massive oil spills. And believe me, it's very challenging to mitigate and monitor an oil spill without using advanced techniques. So I used remote sensing with other geospatial techniques to investigate and identify and detect the oil spill into the marine environment. Why too much disturbance? Okay. So these are the main objectives which have been achieved during this study. Number one, detection of oil spill using synthetic aperture radar. Why I'm highlighting this synthetic aperture radar over and over again? Because it can be used in all weathers, and it is not affected by day or night because it does not need any out illumination source. Number two, to analyze the trajectory and weathering process of oil spill. Number three, to check the impacts of wind and currents on the movement or fate of the oil spill. And number four, to validate the genome and AUDIO's weathering model. It's not moving. Okay. So basically, this study was conducted over Indian Ocean. There were two reasons for that. Number one, I was interested to investigate the oil spill that happens in Pakistan. Along with that, I have studied 3 other massive oil spills of Indian Ocean at the different geographical location under the different meteorological conditions with different oil type and different source of oil type. Why Indian Ocean? Secondly, its northwestern coastal areas are rich in oil. So 2 major oil routes are passing by this ocean that are making it more vulnerable to oil spills. And of course, oil extraction activities are also taking place in those areas. So this area is always at the high risk of oil spills. This table is showing the details of the studied event, like the location, which country they have happened, and their coordinates, event, pre-event date, post-event date, and late post-event date. How much oil was spilled and what oil type was spilled in each event. Before moving to the core methodology that I have applied, I just want to explain how SAR works to detect the oil spill. Basically, oil, as I've mentioned earlier, it makes a waxy coating or smooth surface over the ocean. And when the signal, SAR signal strike with that, if you see over there, with strike that oil spill, it goes away from the sensor, and very weak or no signal return back to the sensor, and that area appear dark. But for that, there should be a certain wind range will be there. If there will be no wind, then the other adjoining ocean will also behave like a smooth surface and like a mirror. And if there will be too much wind, then again that small capillary waves will generate over the oil as well, and very bright signal will return back to the sensor, and again it will be impossible to detect the oil correctly. This image is also illustrating how SAR detect the oil spill, and we can get a perfect oil mask from the SAR imagery. When it takes image from the input image after the pre-processing, when values are converted from linear to decibels, oil shows lowest values, whereas clean sea shows highest values. And we take that difference between those values and set our threshold accordingly and find out the oil mask. Because I have studied weathering process of oil spill as well. So what is the weathering process? Mostly people think that weathering means it's only related to the landsliding or some other features, but or rocks or something like that. But oil also, a weathering process is also taking place in oil as well. When oil discharge into the marine environment, under the influence of winds, currents, salinity, and temperature, it starts degrading, and some part of it evaporate, some part of it may be dissolved, some may be dispersed, and some may be sink into the lower ocean layers. That all process called oil spill weathering. So this is the main methodology which has been adopted during this study. The data I have utilized is SAR, as I've mentioned earlier. GRD, ground range detection product, I've utilized. If someone of you is working already on SAR, you must be knowing it has three products: GRD, SLC, single look complex, and OCN. OCN means ocean. And I have taken IW mode, inferiometric wide swath mode, that is approximately equals to 252 kilometers. And I've used VV polarization, but dual polarization mode is also available, and its revisit time or temporal resolution is 6 days. Along with that, I've utilized sea surface height data that comes in the net CDF format at the 0.25 degree resolution. And sea surface temperature data I've also utilized, that is also in net CDF format and with 0.25 degree resolution, and can be downloaded. This all data sets can be downloaded free of cost from the given websites. The core methodology of oil spill detection can be divided into four parts. Number one, image pre-processing. Image pre-processing, few steps have been taken. Number one, then calibration, then speckle filtering, means the smoothing of the image. Okay, to remove the noise from the image, and then multiple it increases the image interpretability, and then the lens mask means to eliminate the to detect the oil spill. This is same. This equation is representative method. Parameter extraction. There are so many meteorological and geographical parameters which can cause noise in the image, like lookalikes. Lookalikes wind field data is because wind directness. It was actually estimated or delineated from the same SAR predict oil movement in next few hours, next few days, or next few months. Okay, for that I've used genome model. Its results are also very reliable and very good. For weathering model, like the of detection and weathering, wind field and all, I'm just going to show you one. It's not moving. Okay, so these are the results of oil spill detection. I just explain the first image, Chennai oil spill. Okay, A part of oil Chennai oil spill is representing the pre-event image when there was no oil spill. You can see no oil-like phenomena is present in the image. Whereas if you check the B, you see a lot of that is actually detection to identify the oil spill, which was like to eliminate all the look-alikes. The classification, those impurities were look-alikes were removed and actual oil mask was generated. So the same methodology has been applied on all 4 events, so I'm not explaining all of them. It takes too long. Okay. This is basically showing movement of oil in the SAR imagery. At that red color is showing oil spill, and you see the movement of oil spill from 29th to 31st January 2017. It is shown just in the imagery of SAR. Okay, so why I took that step? Just to check the performance of our genome model for the trajectory prediction. If you see the location of oil spill in the next few days, you see from 29th to 31st January in the case of Chennai, it is showing the movement of oil from the actual event date and in the next few days hourly. We can check the movement of oil hourly, what happened with that oil, where it has actually moved after the event. And then when, if you see the D part of this A, the D part of A, here we actually calculate the difference between modeled prediction and actual SAR data, the data which was retrieved from the SAR imagery. So there were no such great difference between both of them. So we can say that the results of our models were reliable in all the cases. And if you check the next Sharjah oil spill, you see the oil was more, it was observed that oil was more in the C image if we compare to B. Why? Because the source of this oil spill was seabed leakage, and it continued. That's why it increased with time. These are showing the wind condition at the time of the oil spill. This data was derived from the same SAR imagery, but it has some issue. Can some of you identify what problem this data was having? Can you check? Can someone tell me what's wrong with this data? Nobody? Okay, if you check at this point. Now, did you see what's happening over here? It's 180-degree ambiguity in these two pixels. It has to be on this direction, but it's showing the opposite direction over here. So we need to eliminate or extract these bad pixels from the image, and then I used OC and product of SAR data, and then regenerated the wind rose diagram that are actually showing the situation of wind direction and speed at the time of the spill. These are showing the results of like current, speed, direction at the time of the spill, because current and winds are they are having strong impacts on the movement of the oil. That's why I have plotted this all data. Okay, so these are the results. We can call it oil budget, or we can say oil weathering. Like this ODIUS model, when we put accurate parameters, different parameters, as you can see, what type of pollution it was, what was the wind speed, what was the wind direction, salinity, sea surface temperature. When we provide all these parameters to the model, then it predicts how much water was how much oil was dispersed, how much oil was evaporated, and how much oil was still there after few days, after few hours. You can run this model according to your desire. Okay, so these are the same results for Al Khairan and Pakistan oil spill. Same model input was given in the case of these two, and these were the results which have been generated by the model. Now, coming upon the conclusion, in my case, VV polarization and SAR data gave us very accurate and good results, and we can find a very good contrast between oil spill and remaining ocean water. So we can detect our oil spills perfectly from this, from these images. And pixel-based clustering is very good technique. It gives you accurate results, but only if the wind speed is at a certain range, like from 3 to 9 meters per second is ideal wind range, where it can identify this oil pixels accurately. Then oil trajectories and prediction, why we need that? To check where oil will move in the next few days and where it can cause what kind of damages. And a weathering process is necessary to check how much oil was remaining on the ocean surface after a few days, so that cleanup operations can be initialized according to that. ODIUS model also have very good performance, but if you give it accurate parameters. If your parameters are not accurate, then it will not give you good results. So it means user expertise are desired to use this. Some key findings. Okay, remote sensing techniques can give you very good results to detect oil spill, to monitor its trajectories, its fate in the of the future. But the main issue is that in your SAR data, there could be a lookalikes problem. It's very challenging to extract this lookalikes from the image. So you have to use extra steps, extra methods to deal with this issue. High furnace oil, its evaporation rate was very high, and bunker oil, the evaporation rate of bunker oil was very low in this study. And wind field can be delineated from the SAR imagery. So if you need real-time data, you can use SAR images to delineate the wind direction and wind speed data of the same images that you are using for your study. Future recommendation, I just use VV polarization for my study, but you can use quad polarization system or dual polarization system to make it more accurate, maybe if you are taking some other part of the world. And number two, this method should be replicate with the global shipping routes. So we can check what's the risk of oil spill with those global shipping routes. Then ecological and economic impacts can be also investigated. In one of our recent publication, we have checked the impacts of oil spill on vegetation and air quality. So it can be done in a different ways as well. So I used simple techniques, but machine learning and deep learning techniques can be utilized for more accurate results and more, for the larger area. And this method can be shifted to the cloud computing platforms so that we can analyze more and more images, because it always needs too much computational power, and our systems usually are not able or not capable to do that. So if we do it on the cloud computing platforms, then we enhance our study area as well. Okay, these are my publications, only 3 so far, and that's all from my side. Thank you so much. Now now you can ask any question, or if you have any feedback or any suggestion, you're most welcome.
Before asking questions, some of you are continuously talking, some of you are even sleeping. Even if you guys are not interested, then you can leave. You're not bound to sit here and disturb even the presenter. I'm sorry for being too rude, but you were disturbing the audience. Now, if you have any questions, you can ask.
If anyone is working on SAR data or marine environment or something like that, you can ask any question. If you if you attend this lecture attentively, then you must be able to ask something. I speak to, yes.
Great. Thank you for your presentation. Actually, I have just 2 questions.
The first question is, during your presentation on the methodology aspects, that's under oil detection, I wanted to ask the difference between calibration and ellipsoid correction. And then lastly, I also realized that SAR normally has some fuel limitation, which includes its inefficiency to give more information on the nature of the oil spillage, which is basically as a result of the sea roughness and then the wind speed. So I want to ask, how were you able to deal with that, since most of these techniques require large data sets, which actually needs to be trained by the machine learning algorithms? So I want to ask these two questions. Thank you.
Okay, thank you, Emmanuel. First of all, the first question I'll answer first. You said, like, what's the difference between calibration and
Ellipsoid correction.
ellipsoid correction? Actually, ellipsoid correction makes sure that the image, each pixel is representing the true real world. Okay, so sometimes SAR imagery is like not presenting it may be towards this side, maybe because it's taking ascending and descending in both modes. So when we do the ellipsoid correction, it actually fixed on the actual ground. Okay. And the second one, what is the calibration? Calibration is actually, it makes sure that each pixel is truly representing the back scatter of the SAR. Okay, that value. So this is the difference between these two. And all this pre-processing steps are very crucial, because if you are not doing pre-processing, you can't do the core methodology. Number two, the second question is like how we can use it in the deep learning. And
yeah, I was asking that with the two, how are you able to deal with the nature of the oil spillage using the SAR, because SAR does not give adequate information regarding the nature of the spillage, which basically requires you to use big data sets, such as the ML algorithms.
Okay, I'm answering what I understood from your question. In my case, I have taken small patches of the different oil spills. I have not used actually deep learning or machine learning techniques till now, but I am planning to do, because SAR data is too much affected with the currents, with the wind speed, and the meteorological phenomena of that area at the time of spill. If we use or train our model, maybe automated model, so these all problems can be solved, and we can detect our oil spills more accurately if we use all these techniques. Anything else? Is someone else?
Thank you. My name is Nathaniel. Can we please go back to the last slide? I mean, conclusion. We get conclusion.
Okay. Can you please fix it for me? It's again. Conclusion?
Yes, conclusion.
Okay. Go to this. Conclusion. I'm back.
Good. At the second point there, no, the previous slide, please.
Next?
No, the previous one. Good.
This one?
Yeah, that one.
Okay.
At the second point there, I see some lookalikes were detected. So I want to know what are those specific lookalikes, and then how were they detected, and then going forward, what are some of the tools can be used to enhance them, please?
Lookalikes. how we detected them. Yeah, okay, let me explain it to you. As I've mentioned earlier, lookalikes are the phenomena that looks like an oil spill, but actually it's not an oil spill. So there are so many methods which can be utilized to extract those lookalikes from the actual imagery. Let me show you. In our case, if you see over here in this image, you see so many lookalikes. If you compare this and this actual oil spill mask with that image, you see there are so many lookalikes in that. Why? Because in this oil spill actually happens because of the collision of two oil tankers. How? Because of the bad weather. So at the time of the spill, wind speed was very high and there was rain as well. So because of those rain cells and high wind speed, so many lookalikes generated in the image. So as I have mentioned earlier, that we investigate the features when we extract the parameters. Basically, we investigate carefully the actual location of the oil spill, rain cells, if there were any, what was the threshold of the wind, if it was exceeding from the that certain limit, that is like 2.5 to 12, or it's reducing from that. So all these factors we keep in our mind, and then we extract features accordingly, all meteorological features or geographical features, as I've mentioned earlier, and then I applied adaptive threshold technique. I already explained how it works. Like, we take the difference between the values of oil and values of other objects and values of oil, clean sea waters, and set our threshold according to that. And finally, we apply k-means clustering. That also helps to segregate all these lookalikes from the imagery. Is that clear?
Yeah, sure. Thank you.
So no more questions? Okay, thank you.
Thank you, Ms. Saima Naz. So our next presenter is Mr. Assenga, and he's a master student, and he's also working in meteorological office in Tanzania. Let's welcome him, please.
Good evening, everyone. Honorable Chairperson, Vice Chairperson, Secretary, esteemed leaders of NUIST, distinguished the participants, good evening once again.
Good
evening. I'm deeply honored to stand before you, presenting to you a topic, inter-seasonal variability of 2020 temperature over Tanzania during the OND season. My name is Godfrey Thomas Assenga, surname Assenga, and as you can see, the rest are the co-authors of this work. This work has been published on the journal Atmospheric and Climatic Science under the publisher Scientific Research. and it was published this January 2020, year 2025. My presentation will follow this structure. I will start with the background, then objectives, study area, data and methodology, result and this discussion, and then I'll conclude. Let us start with the background. What is ISO, interseasonal oscillation? These are oscillations characterized by periodic atmospheric fluctuations on a time scales ranging from 10 days to 90 days. These oscillations is driven by the phenomena like Madden-Julian oscillation, or MJO. Previously, it was believed that ISO, MJO is the ISO, and ISO is the MJO. But later, it was discovered that there are different periods, different time scales of these oscillations. And now we can divide them into several other oscillations according to where they occur and the scales, time scales. Now we can discuss them under biweekly oscillation, or sometimes we term them as the quasi-biweekly, because biweekly means weekly. So when it exceeds or below, then we can call them quasi-biweekly, or the Madden itself, which is prominent. And also, we can have the one which has been discovered on the Northern Hemisphere, BCISO, and this is like MJO, but occurring during the Northern Hemisphere summer, etc. This start by Mpeta and Jari, 2001, quantified the prevalence of this period in East Africa, because, of course, MJO first was believed to be the tropical phenomena, the issue at the tropic. And it was believed to, many researchers found it to be of the period between 30 days and around 60. That was MJO, the MJO's time scales. But later, researchers published and established the other time scales of the other ranges, like from 10 days to 30 days, and they termed as biweekly, and the 30 days to 60 days remains with the name MJO. But Peter and Gel, 2001, discovered the signal also was found in East Africa, this 20 to 30. And he found that the component of was biweekly covered around 54% of the variability or interseasonal variability in East Africa. The weather of West Africa is significantly influenced by subtropical high pressure system. We have 4 systems which are influence weather in East Africa. One is the high pressure systems. One is mascaring high. These are pressure system, okay? They are pressure systems. So one is mascaring high. Second is St. Helena high. Third, Azore and the Arabian Ridge. These systems drive cross equatorial winds and atmospheric circulation patterns, playing a crucial role in modulating interseasonal variability. For example, the mascaring high and its associated circulation have been linked to a seasonal variability over East Africa. However, their influence on interseasonal temperature oscillation, particularly biweekly oscillation, remains understudied. This topic has been studied well in the Northern Hemisphere, but in the Southern Hemisphere is understudied. So this is a gap for every one of us. If you want to study interseasonal, you find it, there is a very big gap in the Southern Hemisphere. This study investigates the biweekly oscillation over Tanzania during the OND season. Why OND season? Because in Tanzania, OND season has challenges. This season is accompanied by long dry spells, which affects the farming activity in the country. So we think understanding this season is of crucial importance. Now, objectives. The main objectives of this study is to review the presence of interseasonal variation in temperature. Of course, as I've said earlier, Mpeta highlighted that this signal, this component exists, but does it exist in temperature? Now, this objective, the main objective of this study is to try to discover or to review if this variation exists in temperature, and analyzing its time evolution. If it exists, then we have to know how it evolves with time, and it is associated with the system. We want also to know the system associated with this system. Now, this instead, I aim to investigate and address the following research questions. We have research questions. Number one, is there evidence of interseasonal oscillation in temperature over Tanzania during the OND season? First, you want to answer this question, and the objective accompanying this question is to establish the presence of interseasonal oscillation in temperature over Tanzania during this season. Second question is how does the composite time evolution of temperature and its related climatic variable behave during the OND season over 2020? And the objective from this question is to analyze the composite time evolution of temperature and its related climatic variable during the OND season. Third question, what atmospheric circulation patterns are associated with the interseasonal temperature variation, if it exists? And the objective is to identify atmospheric circulation patterns associated with the interseasonal temperature variation over Tanzania. And the fourth, which areas exhibit significant interseasonal temperature variation? Now we test the significance. And the objective is to evaluate areas of significant interseasonal temperature variation and the associated atmospheric circulation patterns. These research questions and objectives lay a groundwork for exploring interseasonal temperature variation and the atmospheric associations as it is outlined in the next sections. Now, study area. This is my study area. And as you can see, this is Tanzania. And the dots with the gray background are the observation stations where we acquired, where we collected the data using this study. And as you can see, the study area is the country which is in the eastern part of Africa and bordering with the Indian Ocean. It can be seen in the small map. And the rest you can see the elevation of the country. This region here, as you can see from the moving cursor now, from the moving pointer, this this region here has low elevation, this region. And we have the northern islands, somehow higher elevations, and the southern islands who have higher elevations. Now we see how these elevations are related with the temperature, spatial temperature variability. Our study area, challenges and opportunity. Tanzania faces challenges like climate change, food insecurity, water scarcity and the health issues driven by resilience and rain-fed agriculture. Tourism also is facing challenges due to climate change, and Tanzania depends on tourism on about 17% of its GDP relies on tourism. And it is also impacted by the temperature variability, leading to a broader ecological impact like altered animal migration patterns and the changes in vegetation, further disrupting the tourism and the agricultural sector. As it has been observed globally, climate change is also influencing Tanzania. And as you can see, we have the temperature trends for Tanzania. And you can see recent years, the trends are high as comparing to the normal, previous normal pre-industrial normal of temperature. And this is, as it was also being highlighted by Kabanda 2020 and the Chang et al. 2017. Study area, and here we are studying, we are discussing climatology of Tanzania. And you can see this is annual temperature for Tanzania. And the annual climatological temperature shows that the areas around the Indian Ocean is somehow warmer than other regions. So the reason here, it might be because first, it is near the Indian Ocean. Second, it is the issue of elevation we talked about. So you see this area is warmer than the rest. And this is for OND. For OND, we see the warmer region is more to the south. Why? Because during OND, the sun is in the southern hemisphere. So we expect more temperatures to be observed in the southern part. As you can see, this is OND, and the northern part is relatively cooler as compared to the southern. And this is time series, climatological time series for temperature. As you can see, this incorporates the annual cycles, and the annual cycle indicates that we are the coolest month of the country is during July and June and July, while we have highest temperatures in October, November, and December, making this month proper for studying temperature. As you can see, we have two rain seasons. We have March, April, and May. And we have OND, meaning October, November, and December. But you can see OND has higher temperatures. That's why it is appropriate to choose the OND in place of MAM. We have also OND climate time series. This now has reduced the effect of annual cycle. Now you can start seeing the variabilities. The ups and downs, variabilities. And this is because we have reduced the influence of annual cycle. Data and methodology, again, we have data now. This study utilizes the observational maximum and the minimum temperature. Data from 18 stations all over Tanzania. This data passed several processes of validation, and through these processes, we selected the 2020 year. We had 5 years. We have data for 5 years, but we selected the 2020 because it was the year with fewer missing data. We wanted to have more data. So the year with fewer missing data was 2020, and that's what we used in our study. For further analysis, we use the INSEPDO analysis tool for further study, because this one, we have only one here, because finding a daily data, observation daily data for 30 years, 40 years is difficult. So we used this for validation, but we shifted to reanalysis data. Methodology. Methodology. First, we use the temporal analysis. Time series analysis seeks to identify patterns such as what we were explaining, annual cycles, trending. That is the first thing we can do in temporal analysis. It involves calculating temperature anomalies, applying moving average, and the trending to decompose the data into cyclical and seasonal components, along with analyzing stationary processes to effectively capture intraseasonal temperature variability. Another method used was the power spectrum analysis. Before saying yes, now let me study this regime, let me study this time scale. You must ensure that that time scale is significant. So how do you know that component of variability does exist? We can use the power spectrum to see which component is dominant in our time series. So this method is used to transform time series discussed in the previous section to a periodic domain. Then this domain is identified by assessing the level of significance for different cycles period and select the pattern which pass 95 confidence interval. Now this pattern is selected, and from our view, we're going to see that the 10 to 20 time scale pass this confidence interval. That's why we could proceed with it. And the power spectrum method is powerful method, and it has been used by the researchers, as it can be seen from the screen. Bandpass filtering. Then after understanding that our time scale passes this level, significance level, we use that time scale in the filtering. So we ensure that we are sure that our 10 to 25 was significant. So we used this time scale to filter it out so that we can continue with our analysis. And we use the Lancôse filtering, which minimizes the spectral leakage. And the Lancôse also maintains the overall shape and the timing. And the Lancôse filter is the computational efficiency and the no-phase distortion in this method. That's why we prefer it over other like Fourier transform and the Butterworth analysis. Composite analysis. Now, after understanding that, okay, this time scale is significant and we filter it, now we want to see the average of this variability, because we don't want to analyze the variability which is just by chance. We want to see does this exist in average? That's why we use composite analysis, and it is a very crucial method in our analysis. And we can see the plots later of how they can display the results. Now, another method is now test of significance. We want now we have already maybe revealed the presence of interseasonal variability, but we want to use a statistical method to test the significance of the variability. Now we will use the two-tailed student test for comparing two data, like comparing warm phase and the cold phase, and we can use the statistic t-test for testing the significance. But it is not used in this part because this publication is just a small part of our broader research on intraseasonal variability. So we just ended it there. Results and discussion. Temporal analysis of OND season. Now, as you can see, from this time series, from the filtered time scale of 10 to 25, we can see the sign of intraseasonal variability. We see the oscillation, the sign of periodic oscillations, as you can see here. So it is from the raw data, we see the signs of this indicates that our overall data, there is this oscillation. Before you filter, you try to see the overall data. Does it have this signal? Or it's just you filter small data and you get the oscillation, but you see this signal present over in our time series. Now, resulted from the power spectrum. As I said, now look at the power spectrum. The area with which passes 95% starts from 10 to 25. As you can see, this area passes what? Passes our significant test. And considering individual stations, we also find that separate stations behave the same, have similar behavior. So this gives us go ahead on filtering this part because it is significant. Filtering method. Now, the filtered part, as you can see, the bars represent the moving average of our data. And the dashed red line shows our filtered of our 10 to 25 filtered signal. As you can see, we have this intraseasonal curve as shown in on the figure. Now, the average of this gives you this time series where you have we have several phases. We have neutral phase, we have warm phase, neutral phase again, then we have the cold phase. So this can give us these two distinct phases, warm phase and the cold phase, which we will try to analyze. Now the same like this figure, but it's in a spatial. We have this spatial time evolution. As you can see, we did it using both. We used as you can see, we used the warm peaks, and then we use the cold peaks. Using warm peaks, we can see at day 8 we have the cold, relatively cold, while at day 0 we have relatively warmer, and at the positive 8 we have relatively cold. It means it is a 16 cycle temperature variability, which falls under quasi-weak oscillation. And when we use the cold peaks, we get something like a mirrored result. You see, the place where it was a warm, now it is cold, and we have warm and cold on the negative 8 day and the positive 8 lag day. Then we try to see, is this variability significant? Then we took only the peak phases, and we see first one peak. When we tested the significance in the one peak, we found that it is significant over all of the region over Tanzania. As you can see, these lines indicates the areas of significance. And when we take the cold peak, we also get most part of Tanzania is also has a significant variability. So it means that we have two peaks which are significantly reflecting the variability of temperature over Tanzania. Now we want to evaluate, we want to analyze the systems which are associated with this variability. Doing that, we tried to plot, the time evolution of wind and see how this wind evolution takes place. But behind, we see, we plot it together with we overlaid it with the temperature. And as you can see here, the contour, the field contour indicates the temperature, while the aquifers shows the wind direction. Now you can see during the cold phase, we have anomalous cyclonic flow, as you can see at the Mascarenhas, and this flow extends to the study area Tanzania, as you can see. And during the warm phase, we see warm phase red indicating it's warm, and we see now it is not a cyclonic flow again, it is anticyclonic flow over the Mascarenhas, and the influence is being extended to study area Tanzania. So we have seen that there is a link between the variability over Tanzania, temperature variability over Tanzania, and the wind patterns. But to emphasize on that, I use the streamlines and pick only the two peaks. We took cold phase and warm phase, and this is what it shows. It reveals. We see this because, as you can see, it is still showing anticyclonic, and we see the extension. We see the extension of these streamlines from the Mascarenhas to Tanzania, coming back like this. And in one phase, we see there is a reverse of direction from cyclonic flow. Now it is anticyclonic, and it is also extending towards the study area Tanzania, as you can see the streamlines. Now we want to see, is this change significant? So we also use these two means, and we use the two-tailed student test for significance. We use the cold phase against the warm phase, and we got this. The difference is significant. The difference between the cold phase mean and the warm phase mean is significant over the study area, which is marked green, as you can see. It is gray. The gray color here represents the significance. So the whole Tanzania shows that there is a significant change of temperature during these two phases. Then, what is another system now? We use the another variable. We use the geopotential height to try to investigate if this also has a link with what is happening over Tanzania. Now, look at the figure. We see from day -8, lag -8 to lag positive to lag 0, and from lag 0 to lag positive 8, there is anomalous system moving from lag -8 to lag 0. We see the eastward moving of anomalous high. This is a geopotential key, and it is indicating that the area which are red are highs. So we can see we have this anomalous moving of high centers from west to east, and it shows that it is moving with the time scale of 10 to 25. That's why when you go to another, when you start from lag 0, we have another system moving, which is the low. marked with blue centers. And this movement has been shown with the green and the red arrows is shown on the figure. I think everyone can see. But this is not happening at the study area. This is happening in the subtropical region of, we can say it is happening in the southern hemisphere of the mid latitudes of the southern hemisphere. Let's put it like that. It is happening in the mid latitudes of the southern hemisphere, and the influence incorporates the systems which are in the Mascarenhas region. Now, our study, our paper ended here, but as I said, this study is the part of the broader study, is the part of the broader research. In our research, we tried to investigate how other systems are related with the variability, and we also tried to quantify the link between this system now, because this is in the mid latitudes, how this system in the mid latitude now is related to the temperature variability over Tanzania. Conclusion. Key findings. This research has provided a valuable insight into the intra-seasonal variability of wind of T2 meter here is the surface temperature over Tanzania, revealing the periodic fluctuation with a dominant of 10 to 25 day period as related by the power spectrum analysis. These findings are crucial for enhancing the understanding of region climate dynamics. The study revealed MJO-like anomalies high and low systems we saw in geopotential height, regulating Tanzania temperature variability through periodic reversal in wind direction. During the cold phase, the wind exhibits northwesterlies, as you saw here. Let me call it, you can see the wind, the direction of the wind. They are coming from the northwest. But during the south, during the warm phase, the wind are southeasterlies, as you can see, the arrow. Okay, that is part of our finding. Implication. This finding underscores the importance of intraseasonal variability in understanding short-term climate dynamics over East Africa. The linkage between subtropical system, specifically Mascarenhas, and the local temperature variation suggests potential for improving forecasting model for intraseasonal weather events in Tanzania. Recommendation for future directions and recommendations and future directions. Future research could further enhance the understanding of temperature variability over Tanzania by examining this variation manifested across multiple seasons, because we took 2020 as a case study. But once you find it is happening, once you find the result is true for 2020, the study, and now you will want to know whether this is the case for other years, right? Or whether this is the case for the climatic years. Climatic years should contain more than 30 years. So this is the gap now, and it should be addressed in the future study. Encourage further research into interaction between subtropical pressure systems and interaction and the intraseasonal oscillation to enhance predictability. So quantifying this linkage will be of importance in the future study. Advocate for incorporating these findings into regional climate model to improve early warnings. If you can use these results, you can incorporate these results in the model, then it will underscore the importance of studying this. This study highlights the intricate interplay of atmospheric systems shaping Tanzanian transitional climate variability, paving the way for enhanced understanding and better climate adaptation strategies because of the rain-fed reliance of our country in agriculture. Then we need adaptation strategies, and we need to have accurate prediction of weather, and studying transitional may be one of the solutions. Acknowledgement. Now we have this list of people who contributed. We have my supervisor, Shuang Yang. We have the Director General for providing the data. We have Mr. Danish for his assistance also. We have Mtupil and Charles Ntigwaza. And the link to our paper is, as you can see. Thank you.
No questions?
Thank you very much for a well-narrated presentation. I have some few issues concerning your presentation and the study in general. The first thing I have noted is the issue of the stations. You showed us a lot of stations, but I think you used a few of them. And I don't know if they are representative of the entire country. Also, the issue of the OND, October, November, and December 2020, you said you selected October, November, December 2020 because of the issue of the data availability, particularly the daily data for temperature, isn't it? My question is, why October, November, and December 2020? What is which is the peculiar thing that the peculiar issue that you want to explore from that year? Is it the warmest year in record for that country? Or why, the reason behind? If the issue of the data, in your study, you also used the reanalysis data. So I think you can use, or you can do in any year, if the issue is the data. So maybe you may have another reasons to why you use the OND 2020. Also, you have, I see the products of the winds. The products didn't show the level of the wind systems. I don't know which system did you use. The level did you use, 850, 500, or 200? I think it's better also to clarify that. Thank you very much.
Thank you. Thank you for the good questions. First of all, let me answer the issue of data. Why 2020? We didn't spot a unique event. We just wanted to, first we wanted to find a case study. And the case study can take any year. Second, we are the data for 5 years. From 2018 to 2022. So I wanted to take the year with less missing data. Observational, because once you want to make an investigation, you want to validate your data with the real data. So if your real data has many missing data, then your validation also will have a problem. So for validation, we wanted to use the year with the less missing data, because through this year, we can see the events and compare it with the events in the reanalysis data and see whether this data can be a good representative for the study. So we saw 2020 had less missing data and we used it. It's just as a case study. Now, if we want to study other years after you have found the result from this, now you can use the same methodology to study the rest of the years with no problem. About the why OND, it's because of the variability of this season. OND in Tanzania is more variable than MAM. We have two seasons, MAM and OND. Now, OND is more variable, and the season with more variable, it has more implications to the farmers than the one with less variability. So if we wanted to say, to save the community, if you wanted to have more, to have a study with the most impact, you must study the season which is highly variable. And we found that OND have that qualities. Another question was the rest wind patterns. Okay, let us see if it is wind patterns. It is 500 millibar, and why we used that wind patterns. Okay, I didn't include it here. Okay, sorry for that. But the wind patterns are of 500 millibar level. Why? Because we assessed all levels and we found that the level with clear patterns was this 500 millibar level. That's why we used it. And I should have shown it here, but it was just an error. Thank you.
Thank you so much, Mr. Assenga, for your presentation. And thank you so much, everyone, for joining and coming and taking all the time. And I would like to invite you all on the stage for the group picture. Thank you. Come on the stage, please.